Let us talk about this question. What does the question say? Find the value of sine 75 degree. Now how do we go about finding the value of sine 75 degree? 75 degree is not yet a standard angle, but from now onwards we would also like to remember. After finding this value, we would also like to remember this value of sine 75 degree. Now what does sine 75 degree look like? 75 degree is actually the sum of 75 degree is actually the sum of two angles whose values are well known, 30 degree and 45 degree. We know sine 30 cos 30, we know sine 45 degree cos 45 degree, we know all of those things, right? 75 degree is actually a sum of these particular angles, right? So for finding sine 75 degree, what I'll do is I can write it as sine 30 degree plus 45 degree, right? And after writing it as sum of two angles and then sine, we can apply the formula of sine A plus B. Now what does the formula of sine A plus B look like? Sine A plus B is actually equal to sine A cos B plus cos A sine B. This is what it looks like, right? This is what it looks like. So we can apply that formula. Okay, let's do it. This is sine A plus B, which is sine A cos B plus cos A sine B. This is what you have. Sine 30 degree cos 45 plus cos 45 degree sine 30. Sorry, sine 30 cos 45 plus cos 30 sine 45 degree. That's what you get, right? I hope that's correct. Yes, this is correct. Sine 30 degree. What's the value of sine 30 degree? We know that sine 30 degree is 1 by 2. Cos 45 degree is 1 over root 2. Plus, what's cos 30 equal to? Cos 30 degree is root 3 by 2. Sine 45 is 1 by root 2. So this is 1 upon 2 root 2 plus root 3 over 2 root 2, and yes, this gives me the value root 3 plus 1 over 2 root 2, and that is my answer. This is the value of sine 75 degree. Should we remember this value? Yes, for future prospects, yes, you should remember this value. What other values along with this can we remember? We can further remember that sine 15 degree. For sine 15 degree, what we would be required is 45 minus 30. Can you observe? This would have been 45 minus 30. There would have been minus here, minus here, minus here. Okay, this term would have been minus actually, and you would have obtained root 3 minus 1 by 2 root 2. Okay, sine 15 degree is also equal to, by the complementary angles rule, this is also equal to cos 75 degree. Okay, sine 75 degree, as you can clearly observe, is root 3 plus 1 over 2 root 2, which will be equal to cos 15 degree, right? This is 15 and 75, the sum is 90 degree. These are complementary angles, right, of each other. And on the basis of this, I can define something called tan 15 degree. Tan 15 degree would be sine 15 degree upon cos 15 degree. That's the ratio of these two, right? Ratio of these two would be, the 2 root 2 will get cancelled, and what you get is root 3 minus 1 upon root 3 plus 1. And the important thing is that you can further simplify it by rationalizing the denominator. By rationalizing the denominator, what you will get is root 3 plus root 3 minus 1 upon root 3 minus 1, that will be root 3 minus 1 whole square upon 2, and this will further convert to 2 minus root 3. You can simplify that further, right? This is another value. But tan 15 degree can also be equal to cot 75 degree, right? So if you ever see cot 75 degree, will you be able to tell the value now? Yes, you will be able to tell the value now with the help of this, right? Although you can find tan 15 degree directly as well. Tan 15 degree can be found in this manner as well. Tan 15 degree can be written as tan of 45 degree minus 30 degree. We know tan 45 degree, we know tan 30 degree, and we can simplify that to get this value. That will not be difficult, right? Okay. Similarly, can we also find tan 75 degree? Yes. Tan 75 degree can be found using the general method, or you can find tan 75 degree from here and memorize this. Tan 75 degree would be sine 75 upon cos 75, this upon this. That will be equal to root 3 plus 1 over root 3 minus 1, which will actually simplify to this 2 plus root 3. Now tan 75 degree is also equal to cot 15 degree. This is equal to cot 15 degree. So we'll remember these values, right? We'll remember these values. Along with this, we'll remember one more thing. And what is that? 15 degree in terms of radians. Now 15 degree in terms of radians, what is that equal to? So 15 degree in terms of radians would be equal to pi by 12. Not only that, 75 degree in terms of radian is 5 pi by 12. These are two standard angles which you can remember from now onwards. The values, first the values of sine 15, sine 75 degree, tan 15, tan 75 degree, on the basis of which we can also find these, right? Cos 75, cos 15, cot 75 and cot 15 degree, right? These are some values which you remember. But instead of 15 degree, if you encounter radians, so you should not be worried too much. What you'll have is sine 15 degree is same as sine pi by 12. So if you see sine pi by 12, yes, you know the value of sine pi by 12 now. Okay, so in any case, if you see such kind of question again, or such kind of values, if you're asked such values, you'll be able to answer those questions as well, right? Is that all? Yes, that is all for this question over here, along with some extra and useful information for you. Let's move on to the next one after this. How do we find tan 15 degree, right? We just saw the value of tan 15 degree. If you may recall, we've just solved and found the value of tan 15 degree, but can you actually solve this tan 15 degree directly using 45 degree and 30 degree? Maybe, yes. Now 15 degree can be written as 45 minus 30 degree. So tan 15 degree is equal to tan 45 degree minus 30 degree. And tan of A minus B, the formula of tan of A minus B, can I use that? Yes. Tan of A minus B looks like tan A minus tan B over 1 plus tan A tan B. Okay, this is simple, yes. So this is tan A minus B, which is tan A minus tan B over 1 plus tan A tan B. This is what you get, right? Tan A minus tan B upon 1 plus tan A tan B. Now what is tan 45 degree equal to? Tan 45 degree is 1. What is tan 30 degree equal to? That is 1 upon root 3. So this is 1 minus 1 by root 3, which is upon 1 plus 1 times 1 by root 3. Now what does this simplify into? This gives me tan 15 degree can be written as, we'll have to take the LCM. This is root 3 minus 1 over root 3 whole divided by, this is root 3 plus 1 over root 3, and yes, this one further simplifies into root 3 minus 1 over root 3 plus 1. And on rationalizing, what does this simplify into further? On rationalizing, that is multiply with root 3 minus 1 and root 3 minus 1 over here. This gives me root 3 minus 1 whole square upon 3 minus 1 in the denominator. Can you simplify this square as well? Yes, this will be equal to 3 plus 1 minus 2 root 3 whole divided by 2. What is that? This is 4 minus 2 root 3 over 2, or we can say that tan 15 degree is equal to 4 by 2, which is 2 minus root 3. Right, this is the final value, and that is my answer for this question over here, right? But if you heard the first part, you would have already found the solution using some other approach as well, but this is the actual solution that the NCERT people would want you at this location, right? This tan 15 degree is equal to 2 minus root 3. That is your answer. Obviously, there are other approaches, one of which I discussed with part 1, right? And finally, we'll have to remember this, right? Finally, we'll have to remember this one.